guys. Today's is very interesting topic related to the sedimentology and paleoclimatic analysis. So the topic name is PETM, Paleocene Eocene Thermal Maximum. So it's the geological time period in which global warming is a very intense and the average temperature is 5 to 8 degrees centigrade. So you can see it. This is sharp point temperature rise at this event. So how we know this temperature is increasing? So first we see the carbon-13 isotope. So you can see the carbon-13 isotope is gradually or suddenly decreases. So it's mean that the carbon-12 value is too much high. So carbon-12 means like it's too much warm and too much organic matter come into the ocean and atmosphere and land. Another is O18 carbon isotope is also very sharp point, means it very decreases. So O16 is increases, and O16 means like a positive or give the global warming to the ocean and land surface. So here you can see the carbon isotope release. One reason is the methane hydrated or methane injected from the deep ocean very high, and the another is the some people say that there is the North Atlantic igneous province suddenly ejected into the Cretaceous Paleocene, in which the magma come from the ocean or the anoxia rich, and they are deposited in the deep ocean. So the carbon-12 ratio is increases, due to which this event is occur. So this is the two school of thoughts. Which one be okay? So they have different reason. In the north plate boundaries or north plate countries, we have this kind of event or this kind of evidence found, but in equator, when you go to equator, so this kind of symbol or evidence we found it. So PTM result: first, seafloor dies. All the benthic foraminifera species are some are evolved or some are extinct, and the main thing is dinoflagellate, in which pectodinium they are too much because the influx from the land is too much. Number two is the warm water algae exploded. So you know the this neutron flux come from the land, and they are deposited in the ocean, in which the eutrophication is causes. Due to the vitrification, the planktonic foraminifera are the evolved, and they are replaced to the new species. And the another last thing is the flora, which are present in the high latitude, means like in that area like Antarctica or Arctic regions. The ice, below the ice, the flora or the cold bed are present. So it shows that there is event occur in Paleocene time, in which in high latitude area a lot of green environment, a lot of hot cases are present. The sedimentology change along the PTM. First, the carbon dissolution is occur. The lysocline, and lysocline means the where the carbonate dissolution system or carbonate dissolve is shallowing at the PTM, and the deep sea, the bottom water, they are acidic, and they dissolve the carbonate. And you can see in this image the carbon dioxide plus water, they forming the H plus, which they reduces the pH, and they dissolve the different rocks or different carbonates rocks. Number two is enhanced heterogeneous sediment input. So due to the evaporation and too much rain, the land surface from the there is a lot of class in sediments are come through the marginal ocean or deep ocean, at which you can see there is the evidence of the stolnite clay from Denmark, in which rich in kaolinite, and kaolinite is the chemical weathering from the feldspar. So it's mean the too much chemical weathering means too much humidity in the atmosphere, and too much rainfall is present around the atmosphere. Number two is the transist sea level rise. So globally sea level is rises, and sea level rise is favor to carbonate, but in PTM the sea level rise plus heavy rainfall due to the flux of the class in, but they are a favor for the high turbidity and low carbonate, because the class is too much. But when sea level rise only, so the carbonate will be deposited. Red bed and oxidized soil, as I discussed earlier, that These heterogeneous sediments come and the caveolite form, means like chemical weathering is too much, so red beds are forming, and this is the example of some outcrop. And this is the chemical formula. If iron is already present, which react with the oxygen and water, they form this iron oxide, so this red bed form. Number two is organic rich deposit. So due to the high rainfall, the algal productivity or the algal boom is eutrophication is coming, and the water stratification is stratified, means like ocean, deep ocean cold water is mixed with the warm water because the temperature will be same, due to which the trace elements such as molybdenum, pyrite, and they are deposited in the deep ocean. So this is the example of a Danish North Sea PTM black shale, which is you can see in this. Okay, so global versus regional climate response. So at high latitude, 60 degree to 90 degrees north south, the temperature is very warm because it's recently melting of ocean. And you can see the due to the this one, so the pollens and spores and the ACM caveolite is found in this area. And this pollen, you can see the surface is very like very smooth, so it's mean that very too much chemical and too much wind, because they flow easily by this morphology. And also the red bed, so these are the evidence in which it shows that the high latitude warmer climate is present. Another is the 50 to 65 degrees centigrade. You can see the blast is coming and the volcanic eruption is present. So there is recent MIT research is occurred that when there is folding in the zeolites and smectite clay, so the organic matter is attached to this clay, due to which the organic carbon or the carbon dioxide is trapping, and due to the trapping of carbon and not exposed to the ocean, so it decreases the CO2 level. So by this process at PETM, so it cooled down the PETM event, and later on after 2 million, after 20,000 so year, so after this time duration, the temperature is will normal and normal world is come. But this is the role in which they play a vital role for the maintaining the carbon dioxide level, because it traps the carbon. At this latitude, the worm is also drier, and you can see this is the reason from the USA red beds, and this is the reason from the carbonate or soil nodules, which shows the aridity. And also in this latitude, in Pakistan or India, South Asia, we have Patala formation, so they have a tropical land and extreme heat, and which input weather, clay and plant debris is too much due to the monsoon rainfall. And in Pakistan, the upper Indus Basin Patala formation is deposited, and lower Indus Basin, the Dungan formation is present at that time during the PTM event. So you can find this event in these two formation. And in these people are studied, so they see the larger benthic foraminifera like this, they disappear and they change to this into Eocene larger benthic foraminifera, and they increase their size because the temperature is now good. So that's why these are very large size, and these are very low size, and also complex structure, because very nutrient rich environment is now stable after the PTM. And also nutrient rich in this kind of test, you can found the evolution from this planktonic foraminifera to this planktonic Eocene benthic foraminifera. And from carbon-isotope, you can see in northern Pakistan is too less, because in Patala formation is organic rich, so it's mean the carbon-12 is increases, so carbon-13 is decreased, so that's why the value is very low. But the carbon-13 value is very high in South Pakistan, because Dungan formation is carbonate, and the carbonate is the limestone rich, so the carbon-12 organic component is low, so it's mean that the positive signal will be give. So carbon-13 is increased here, but in North Pakistan carbon decreases, carbon-13 is decreases. And you can see dinoflagellate bloom in this area in Rakinala section, and the sedimentary fishes sea level rises after the PETM Patala coal, you can see, and the limestone is present. So you can see this is the events of the PETM in Pakistan, and after post the Namal and upper Indus Basin and Ghazij lower Indus Basin, the deposition is started. PTM shows similar like today climate, like they have in polar the melting star, flooding, and the anoxia is present. And difference is the like the rate is very low, but human derived carbon release is too much high. This is the help to scientists to see the PTM and to compare real ancient data with modern. So you can see the polar warming. Say at that time this all effect is going on, due to which the event is starting. Still these events are now starting. And the another is the ocean acidification. So you can see the ocean acidification is now very rapid start. So it's mean look like the PTM, the acidification is starting and the pH is low. Another is the carbon cycle recovery, but at that time PTM the recovery is low, but in this today's world the carbon dioxide is low, is very high, but the recovery is very low. So these are the last slide in which you can see two ideas nowadays they're working. First, enhanced silicate weathering. You can put the basaltic and in the land at which it will be evaporate, it will be transported and in the ocean, and they will be deposit the carbonate, due to which the carbon dioxide value will be decreases. Another is the carbon side you can capture and you can down into the some oil reserve or in the rock in which they deposit, and they will be precipitated, they will be converted into the solid rock. These are the two reasons in which you can decrease the carbon dioxide, but the rate will be very low as regarding to which we put carbon dioxide into the atmosphere. So you can see these are the some two videos in which you can see the carbon dioxide capturing from the atmosphere. So these are the link of the research paper in which you can read. And thank you so much for the video. I hope you will get some valuable knowledge from this video regarding to PETM, Paleocene, Eocene Thermal Maximum.